Hello and welcome to this little graphics card special. A while ago I started planning to build a retro PC that should cover the period of about 1990 to 1998. And of course I had to find an answer to the question which graphics card would be the best fit. A very important question, and while you can find parts of the answer spread out all over the internet, it's quite hard to get a coherent overview. And some of the answers you will find will probably go in so much depth that they will raise more questions than they answer. And so with this video I want to provide this coherent overview, which will not go into every technical detail, but will hopefully give you a good overview of the general options you got when you're looking for a graphics card for a PC of the 90s. I will tell you which decisions you got to make and which limitations your options come with. I will talk about the different connection options, VGA, DVI and HDMI, the decision between ISA, PCI and AGP cards, and finally I will also briefly talk about the different manufacturers, their special technologies and the dependencies some games have. And with that, let's dive in. First of all, it's important to understand the basic characteristics of VGA, DVI and HDMI. All three of these terms are actually graphics or signal standards, but they are also used for the corresponding ports. However, other signals can also be sent using the same connectors, which can make it a bit confusing. Let's start with VGA, or let's say analog signals which are sent via a 15-pin connector called D-sub, or more precisely DE15, which most of the time got a blue plug. Even though VGA is actually the name for a graphics standard with 256 colors, this name is also widely used for the connection, even though it can also be used for other analog signals such as CGA, EGA and SVGA. And now I need to briefly go into more detail, as some of the stuff I will mention now will be connected to problems later on. Back in the 90s, the graphics cards converted digital data into an analog signal, which was then sent to one of these old CRT monitors. And without going into details on how CRTs work, just know that these analog signals are then just displayed as they were. An additional conversion was not necessary, and it was also not dramatic if it didn't match a standard perfectly. The important part here to take away is that a tube screen had only very few restrictions regarding the format. For a retro PC with games running in DOS, which were released in the early 90s, this is especially relevant for the standard resolution at the time of 320 to 200 pixels, which is interpreted by the monitors as 720 to 400 pixels and getting shown on 70 Hz. While this resolution has a pixel ratio of 16 to 10, the CRT monitors had an aspect ratio of 4 to 3. Accordingly, the pixels were stretched vertically. Since the graphics were designed for these monitors, a modern flat-screen display with square pixels is therefore not true to the original, unless you apply some scaling. If you just displayed the picture as is, characters would appear a bit more fat than they were intended, as the vertical stretch of the CRTs was already factored in back then. In the early 2000s, flat screens found their way into the consumer market. Old flat screens will still be able to accept VGA signals, but unlike CRTs, these screens must first convert the analog signal back into a digital one. And the result from that is often not pretty to look at, also thanks to the now static pixel shape and position. Which signals these monitors can handle also becomes more problematic over the years, and the possibility to process analog signals at all had been gradually disappearing. This is also related to the introduction of DVI in 1999. The DVI signal is digital and comes with more rigid specifications. Resolutions below 640 to 480 and refresh rates above 60 Hz are now potentially problematic. That's probably also one of the reasons why DVI used a two-track approach. While there are DVI connections that can only send and receive the new digital signal, there are also DVI connections exclusively for analog signals like VGA, and a mixed form which can do both. You can easily identify the support for analog signals by checking the white pin on the right side. If it is standing alone, then the connection can only accept or send digital signals. If there are two additional pins above and below, it will also support analog signals, or only analog signals. But DVI which can only handle analog is rare and can mostly be found on adapters. So when choosing a graphics card, you need to make sure that the card as well as the monitor can both either process analog or digital signals. The plug itself only plays a role in so far that it can exclude one or the other option. If you got an analog signal from a DVI connector, you can easily connect that to a VGA port of a monitor using the right adapter. And the same is true for a VGA connector going into a DVI port of a monitor, as long as it supports an analog signal. However, if you have a monitor which only accepts digital signals, then also a graphics card with digital DVI is necessary, and adapters won't be of any help. Even if you got a graphics card for that, you might still encounter problems if you go into DOS mode or start games with low resolutions or high refresh rates. It is possible that your graphics card already converts this signal internally to a more compatible DVI standard, and while the result probably looks rather bad, you would at least be able to see anything. But this is very dependent on the individual graphics card. It is also possible that you simply get a black screen and maybe an out of range warning. It's a similar story with HDMI, where you have to distinguish between the signal and the connector itself, since other signals such as digital DVI can also be sent via the HDMI connection, which makes sense as HDMI basically emerged from DVI. This makes HDMI splitters and switches a much cheaper alternative to DVI ones, if you can find these at all. However, if you send a DVI output of a graphics card to an HDMI input of a monitor, then it depends on the monitor whether or not the image can actually be displayed. For the sake of completeness, I should also mention the output options of S-Video and Composit. However, these analog signals have a smaller maximum resolution and result in a picture lacking sharpness compared to VGA. They are also not using the VGA connector, and you would need a suitable device to display it or an external converter. Depending on what you have available and which quality you want, this can be a viable option. Let's summarize the topic of the different output options real quick. The terms VGA, DVI and HDMI are used for signals as well as for the physical connectors. However, some of the connectors can also carry different signals. The VGA signal of a graphics card can also be transmitted via the right DVI cable, but can only be processed by the monitor if that one supports it. A digital DVI signal, on the other hand, can also be transmitted via an HDMI cable without any problems. But again, there is no guarantee that a monitor with an HDMI port will be able to output the signal, as it may expect a signal according to the HDMI protocol, which actually costs license fees for the manufacturers. If you want to play native DOS games in a resolution of 320x200 running on 70Hz, then you basically got three different options. The first one being to just use a suitable display, ideally a CRT. The second option is to use a graphics card with a DVI connector. That way, the conversion will already be done by the graphics card. The quality and reliability can vary though, and I'd recommend to check for reports by other users for that specific model first. And lastly, of course, there is the option to use a converter. While there are cheap options if you don't worry about quality and if it's okay that some things might not work, really good options will require to have some deep pockets for a data path capture card or a RetroTink 4K. If you are mostly interested into games running on Windows 95 or later operating systems, which basically run everything on 640-480 or higher, then a focus on DVI can make sense, as in this case no conversions are necessary. If required, you could still temporarily connect a VGA-compatible screen to do some adjustments in other graphical environments. Let's move to the next question: which slot to use and what to look out for? Our choice consists of the old ISA cards, cards for the PCI slot introduced in 1992, AGP cards which were first released in 1997, and of course there are also PCI Express cards, but these are too recent to be covered here. Let's go chronologically and start with ISA cards, which you can find with different lengths. The fastest cards are using an extended slot, which is called VESA Local Bus, which is also why these can be called VLB cards. Old boards for CPUs up to the 486 often have no other slots than ISA variations, and in these cases VLB cards will be completely sufficient. In tests by Phil's Computer Lab, the cards from Cirrus Logic have proven to be particularly fast. For boards that support these VLB cards as well as PCI cards, PC Retrotech did some testing and found that on these early boards the PCI cards were minimally faster but also less reliable.
The only difference is that I had a lot more PCI video cards that just didn't work.
Except for PCI cards from S3 Graphics, which all ran without issues. However, if we go beyond the 486 CPUs and from socket 3 to socket 4, then these VLB cards are no longer an option. They just don't exist anymore on these newer boards, so that you can only opt for these shorter and slower ISA cards or get one of the plenty PCI cards which are significantly faster. So the decision is most likely to go for PCI in that case. Time to take a look at the differences among these PCI cards. While initially PCI graphics cards were driven by 5 volts, in more recent years this changed towards 3.3 volts, and this presents a problem if you want to buy a somewhat newer graphics card for an old system that does not offer these 3.3 volts. Boards that only offer 5 volts are those that have the AT form factor and can either only be powered by an AT power supply or offer connection options for both AT and ATX power supplies, such as many SuperSocket 7 or Slot 1 boards. Some of these boards can supply PCI cards with 3.3 volts, but this is the exception and you should check beforehand. Conveniently, there are corresponding notches in the cards to identify for what voltage the cards are intended. The notch for 5V cards is at the back and the one for 3.3V cards is towards the connectors. It gets problematic when it comes to cards with a universal connection, which have a notch in the back and in the front, but then are not so universal in their inner workings and need 3.3V to operate. This can very well happen with newer graphics cards. For example, this GeForce FX 5200 from Zotac from 2003. This card fits in old boards physically, but will not work there. If you want to be sure that the card works on 5V, you should only buy PCI cards that have a notch exclusively in the back, like this S3 Trio 64 V2DX from 1996. However, this limits the already small selection of newer cards quite a bit. If you want to buy cards with universal connectors, you will need to refer to experiences from other users of this specific model, as this is also probably not mentioned in the manual. Basically, you could say that your selection is getting extremely limited for PCI graphics cards for 5V systems around the year 2000, and thus also expensive, and you should probably rather consider AGP. Before we continue with AGP cards, let me briefly mention that there are also long 64-bit PCI slots and graphics cards for that. But while they do exist, they are exclusively for workstations, which is why I will not go into more detail there. So in 1997, the first AGP graphics cards entered the market, and similarly to the introduction of PCI, there are a couple of compatibility problems. Among the first boards supporting AGP like SuperSocket 7, especially boards with the chipsets of VIA and Ali, can have problems with AGP cards from Nvidia. On the other hand, the AGP cards from 3DFX hardly use AGP features and achieve a better compatibility that way. The advantages of AGP are obvious though. The AGP connection is several times faster than PCI, and while early on this increase only causes a minor difference in terms of actual performance, due to AGP replacing PCI, there is also a much larger selection of newer cards. Starting with the Riva TNT2 by Nvidia, you will find numerous offers on eBay for the AGP versions, while your selection on PCI versions will be quite limited. What should you look out for when getting an AGP card? Besides of the before mentioned compatibility problems of Nvidia cards with some boards, you will also come across different versions of AGP cards requiring different power connections. And similarly to PCI, there are cards here that just ignore the physical restrictions and thus can be installed into boards where they won't work or are even causing damages. However, with AGP this is the exception, which is more likely to be encountered if you use old cards in quite new boards. For a normal retro PC, where you tend to use newer cards together with older boards, there aren't many problematic cases though. To make the whole thing a bit more complicated, however, slots received version numbers like 1.0, 2.0 and 3.0, while for graphics cards you will see the bus speeds instead, like single speed, double speed and so on. A SuperSocket 7 board with AGP 1.0 will support bus speeds of single speed up to double speed. However, newer cards, which were released in the AGP 2.0 generation and are made for quadruple speed, should still work here using double speed. If the card runs at 8 times the speed, then you should probably get detailed information about the specific model beforehand if you want to use it on an old board. For example, Phil's Computer Lab was able to successfully use a GeForce 4 Ti 4208X on a board which only supported AGP 1.0. It's the other way around when you use old cards on boards with new standards. There it's more likely to encounter problems. On Wikipedia they mention TNT2 as well as SIS 305 cards, while on the Vogons forums the Voodoo 4 4500 is mentioned. They all can cause damage if placed in newer boards. As third major point, we will have a look at different manufacturers and their technologies and touch on the topic of compatibility again. As mentioned before, cards from Cirrus Logic have done particularly well among cards with ISA VLB connectors. For early PCI cards used with 486 CPUs for example, S3 Graphics seems to have great products. For early boards with AGP slots, especially with VIA and Ali chipsets, NVIDIA cards can cause problems. And while cards from ATI, now AMD, do run, you can see in this chart here that they have problems with some specific old DOS games, and are therefore probably not the best choice in this field. And the same is true for graphics cards by Matrox. But of course, these cards can still work well for later games. And even later 3DFX cards got issues with older games. Starting with the Voodoo 3, there are artifact problems on the 320x200 resolution. However, these can be solved by a graphics card BIOS exchange. While that is not rocket science, it does require that you look into it, and ideally you also have a PCI graphics card available, which, in case something goes wrong, you can use to boot the PC to overwrite the BIOS of the Voodoo in the AGP slot. But now let's get to the topic of 3D rendering, which is being done in various ways. There are also a couple of manufacturers with their own accelerators which didn't really catch on and are only supported by very few games. Among these the S3 Verge with S3D and the ATI Rage cards with their own API CIF. As the use case of these more exotic accelerators is accordingly niche, I will also skip them here. But if you're interested, you can check the video description where you will find links to the full comparison video shown here, as well as to an overview at the Vogons with all the games supported by exotic accelerators. So let's talk about the most important rendering options, starting with the most basic one, which back then was supported by almost every game and all PCs: software rendering. This is the most rudimentary option, which is completely done without 3D hardware acceleration. Within Windows, this can also be done by Direct Draw, a pure 2D renderer which for 3D games usually works together with Direct3D. Using software rendering, the heavy lifting is done by the CPU and the graphics card only plays a minor role in comparison. However, this means that 3D games run extremely slowly in this mode if you're using a CPU from the same time period, while at the same time the graphics also look the most pixelated or grainy, which is why back then you try to avoid software rendering whenever possible. These days it depends on what you think of the grainier but less washed out graphics, especially if you are using a modern monitor, which make the washed out graphics very apparent. However, the prerequisite of using software rendering is a CPU with plenty of headroom. One of the most popular solutions for 3D games from 1996 to 99 is a Voodoo card using the 3DFX exclusive API called Glide. This 3D acceleration not only reduces the load on the CPU by quite a lot, but also improves the image. While the smoothing or blurring can be perceived as more of an issue than an advantage, as previously mentioned, with a 3D acceleration it is also possible to display some graphical effects without a significant performance loss, so that these effects will not show up in software rendering. In Need for Speed 2 SE, for example, you will get some nice snowflakes using Glide. If you play on software rendering instead, you will have to do without it. There's also the curiosity from today's perspective that two of the first graphics cards with Glide support, the Voodoo 1 and 2, are actually pure accelerator cards, which the PC automatically switched to for supported 3D applications. The Voodoo Rush then combined both, handling 2D as well as 3D tasks, but did so with at least a 10% performance hit in comparison to the Voodoo 1. A bit later, however, the Voodoo Banshee as well as the Voodoo 3 were released, which were full 2D and 3D cards as well, but this time also with a great performance. However, as mentioned before, the Voodoo 3 has some issues as well, which can be solved by exchanging the BIOS. And unfortunately, not all games which are accelerated by the Voodoo 1 and 2 are also getting accelerated by the Voodoo 3. For some games that were already accelerated using DOS, you might need to fiddle around with some files, but there is no guarantee that this will then work. Of course, this acceleration via Glide can only work if the games actually do support the Glide API. However, since the cards were extremely popular, game developers tried to make their games compatible, and for several games this support was actually patched in retroactively. Especially with these earlier games, however, Voodoo 3 or later might not be working for the Glide mode. But even if Glide is not supported, the graphics card can of course still use the common other interfaces, which we will come to in just a moment. And software rendering also still remains as option, of course. So all in all, Voodoo cards are very suitable and popular cards for games of the end 90s. However, the disadvantage of all these Voodoo cards from today's point of view is actually this popularity and therefore the according demand and price for these cards. Meaning you won't get any of these cards for less than €100 or US dollars. For games beyond the year 2000, the cards lose their relevance as the company was sold and no further cards were produced. So if you're looking for a card that can still run games from 2005 or that has modern features like a DVI output, then the card from 3DFX is not going to be the best choice. 3DFX was also quite late with their introduction of 32-bit color depth, which they only introduced with the Voodoo 4 and 5 models. Whether you really need 32-bit color is debatable though. Personally, I wouldn't consider the graphical difference as really relevant in games which do support both options. And the choice of games you can play won't be restricted either. Widely used alternatives to the 3DFX exclusive Glide API, whose development was discontinued in 2003, are the APIs OpenGL and Direct3D. They are basically supported by all cards released after a certain point, which I will get back to in a bit, and with these you will be able to run the majority of the games, excluding some of the earliest ones where 3D acceleration was exclusively based on Glide or more niche accelerators. Nvidia implemented a technology called Transform, Clipping and Lighting, TNL for short, in their graphics cards from 1999 onwards, starting with the GeForce 256, and ATI followed with something similar just a few months later with the Radeon 7000 series. Via OpenGL, this new technology could be used, and in games which actually utilize these features, ATI and Nvidia gain a significant speed boost over the competition.
The Voodoo 3 and the Voodoo 5, they don't have TNL, so they kind of top out here.
Among this competition isn't just 3DFX, but also S3, which did actually include TNL hardware in their final card, the Savage 2000, but like a bunch of other things with that card, it didn't function properly.
Direct3D doesn't perform where it should, the transform and lighting engine doesn't work, and compatibility with the S3 Metal API is also not working.
And quite similar to OpenGL in these regards is Direct3D. In this case, however, such features are added with larger patches. Direct3D is a part of DirectX, and the support for TNL was added in DirectX 7. This means that games that only support DirectX 6 will not profit from these advantages the newer ATI and Nvidia cards offer. Newer generally doesn't always mean better and faster if you want to play older games. In addition to compatibility problems, newer cards may also run slower because of limited driver support. This is the case with Nvidia cards from GeForce 3 onwards, a card released in 2001. From then on, drivers are required that no longer perform that well with DirectX 6, for example. They will still work, but of course you have to consider whether you would rather opt for an older card instead. Of course, another factor is your choice of the other components in your machine. Although you can get a lot of performance out of a newer graphics card, at some point the CPU of an old platform will just not be able to keep up anymore, and the system will no longer get faster, but rather more incompatible by adding an even newer graphics card. Finally, I would like to provide a brief overview of some of the most relevant manufacturers and their graphics cards between 1990 and 2005. While you can find a full overview of all models on vgamuseum.info, I try to condense it quite a bit. I left out many models and also a few manufacturers such as Matrox, summarized series or only listed individual representative cards. Also, I left out PCI Express cards completely, which became an alternative from 2004 onwards. At the same time, however, I added information to reflect technical developments and to provide some guidance. I also mention which chips have card models models with DVI connectors. But while they can feature DVI, it should be noted that especially for earlier cards, only very few models actually do provide them. The colored borders indicate how available cards are using the ISA, PCI or AGP interface. A rarity can be reflected in the price, but that is not always the case. On the other hand, the Voodoo 1, 2 and 3 cards are all readily available, but generally very expensive due to their high popularity. During the first years, ISA cards were the only option you had. Notable chip manufacturers at that time were the now rather forgotten Cirrus Logic and S3. It was 1994 when a sudden shift to the PCI interface happened, which then dominated the market for just a very short time until 1997, when AGP began to emerge and to gradually replace the cards with PCI slots over the next couple of years, making PCI versions very scarce by the year 2000. While you do see PCI cards resurface in the 2000s, these use different standards, and you got to assume that they won't work in significantly older boards. Just like AGP, 3D acceleration hardware also got more relevant around 1997, especially with the Voodoo 1 being released in 1996, which became the gold standard. Although some other manufacturers already used 3D hardware acceleration a little earlier, their cards can only be used for very few specific titles, if at all. Cirrus Logic released their first 3D card called the Laguna 3D quite a bit after the Voodoo 1, but it neither supports transparency nor OpenGL, and would then also become the last card of that manufacturer. The first 3D card by S3 was the S3 Verge, and even though it did have its own 3D interface called S3D, that one was barely used, and due to the lack of OpenGL and proper Direct3D support, it is also rather unusable for most 3D games. This only improved after the Trio 3D with the Savage 3D. ATI offered the first 3D hardware support in 1995 with their 3D Rage chips, which also had their own interface CIF. But these also had issues with transparency and direct 3D support. So the first card you should consider there is the Rage Pro with some reservations, or better yet, the Rage 128. Nvidia as well offered 3D support in 1995 with their NV1 chip, which was used in the Edge 3D card. While the card is interesting due to the special tech used there and the cooperation with Sega, and is accordingly quite expensive with around €200 or US dollars on eBay, it is not a card which can be recommended beyond its special use cases due to the insufficient DirectX support. Nvidia's first card which can be considered in that regard is the Riva 128. While Cirrus Logic and S3 released their final and not really competitive cards in 1997 and 1999 respectively, before the manufacturers disappeared from the market, 3DFX reached that point in the year 2000, when they released their final graphics cards, the Voodoo 4 and 5. While the cards are fine and well liked today, due to their short lifespan and accordingly lacking availability, you should budget €300 or US dollars or more for one of these cards. Or of course, rather consider cards from the competition which already had their technical advantages at that time, including TNL hardware implementation. The Voodoo 4 and 5 were also the first 3DFX cards which had models with a DVI connector, which was introduced in 1999 and makes handling with modern monitors much easier. But the Voodoo models which featured them were Mac only, and to be used in an IBM PC, you would first need to do a BIOS flash. They are also accordingly rare and cost quite a penny. But that doesn't mean that the first DVI models by other manufacturers are easy to get or useful. The DVI version of the Rage 128 is intended for Mac as well, but unlike the Voodoo cards, it cannot be modified. And the DVI versions of the GeForce 256 and Savage cards are extremely rare. However, from the year 2000 onwards, which is when the Voodoo 4 and 5 cards were introduced, DVI connectors were not that super special anymore for the remaining competitors ATI and Nvidia, and are therefore much easier and cheaper to get today. And a BIOS replacement isn't necessary there either. Of course, you can also go a year or two further into the future, where DVI connectors were widespread already, and you'd get some more performance on top of that, which you could use to play games more smoothly or in a higher resolution. Especially in the time of the first 3D accelerated cards, you basically had to replace your graphics card every 2 or 3 years in order to play the latest games properly. And unlike in this Gamester magazine from February 2000, These days you would probably not consider a frame rate of 15 FPS as moderate and 20 FPS as maximum gaming fun. It's just important that you keep an eye on compatibility. Compatibility towards the rest of your system on the one hand, and compatibility towards the games you want to play on the other. And with that, we've reached the end of this overview. As you see, your choice for the right graphics card depends on various factors. I hope that this video was helpful in showing these factors, as well as pointing out some pitfalls that you can now avoid. While some of the content in this video is based on my personal testing and experience, a lot of the information has also been gathered from Wikipedia entries, reports at the Vogons forums, as well as videos from channels like Phil's Computer Lab. I highly recommend checking out his videos and website, where you can also find numerous tools and drivers for old hardware. Links to this page as well as many other sources can be found down in the video description. Thank you for watching, and I wish you a lot of fun and patience when putting together your own time machine. Until next time.